Example, we have it's similar to the free body diagram from the first A from the previous question, but there's some numbers and we're looking for some information. So in this case, a 1,000-kilogram car enters a level turn at 20 meters per second, and the curve has a radius of 80 meters, and it's asking what's the centripetal force that friction has to supply if it's not going to skid. So in this case, we see that, let's just draw this out for a second. So here's some circular road. For whatever reason, this car's on some circular path and it's going around. Here's the car itself. Again, I'm going to draw it from the top. This is a situation where you've got 3 dimensions we kind of need to draw. So I'm going to show the whole circle. I know that at this instant the car is moving at a speed of 20 meters per second, right? And as it goes around the curve, the direction this arrow points is always changing. It's always tangent to the circle, and it's always changing, but it's always 20 meters per second, right? So wherever it is, it's the same. Okay, so that's what the car is doing. It's 1,000 kilograms. The other thing that we are told is that the radius of the turn, so the radius from, I don't know, let's put it to the center of the circle, to the center of the car. I'll just make it to the center of the road itself. So this distance is 80 meters. Now, so it's asking us for what centripetal force must friction supply. So in the previous problem, we saw that in order for this car to make the turn, its wheels are going to turn. This is supposed to be an X-ray view of the wheels, and the wheels angle this way, and that causes the car to turn. And what that does is it supplies a frictional force pointed directly towards the center of the circle. So what we can say here is that Fc, so remember we're doing the same physics, Fc equals MAC, MAC equals the sum of the forces. Now instead of our 5 equations for AC, we have a new one. It's mv squared over r, and it's still the sum of the forces. And in this free body diagram, there's only one force of friction. Of course we have a normal force and a force of gravity. The way I've drawn my car, gravity would be pointing down into the board, and the frictional force would be pointing up, straight up, but they cancel out because this car is moving in a horizontal plane. So in this case, mv squared over r equals a force of friction. Part A of A is asking us, there's a lot of A's in this question, part A is asking us what centripetal force must be supplied by friction. So they're basically asking us for the force of friction. And to answer that question, we have to solve all this out. So the force of friction is equal to the mass, 1,000 kilograms, times the speed, 20 squared, divided by the radius of the turn. And the answer to this, if we put it in, let's just confirm that my answer is correct, times 20 squared divided by 80, we get 5,000, which is what they got, 5,000 newtons. So what this question is saying is that without 5,000 newtons of friction, this car is not going to make this turn. Part B asks for the minimum coefficient of friction. So for part B, it's asking for minimum mu. So we know that FF equals mu Fn. That's one of our equations. Well, we know FF now because we know it's 5,000. We can figure out Fn. In this case, it's balanced. So in this case, Fn simply equals Fg, which equals mg, which equals 1,000 times 9.8, so 9,800 newtons, right? So in our example, we can solve for mu. It's just the force of friction over Fn, and we get 5,000 divided by 9,800, and we end up with 0.51. 0.51. There's no units for coefficients because it's just a ratio of the two forces. So what we know is that the the coefficient between the tire and the road has to be at least 0.51. Remember what we learned about coefficients. They're really dependent on the nature of the two materials. So if anything changes, then the coefficient might change. So the question in part C, let's see, part B, if it keeps going, what happens if there's an icy patch and the coefficient just decreases? So here's this big black ice patch. You can't see, the driver can't see it, but he keeps driving and his car ends up hitting this patch of ice. Mu will immediately decrease, maybe it decreases to less, and so what that means is the force of friction, if I was to calculate friction with a new mu, so let's just explore this. So the icy patch. So imagine there's an icy patch that has a mu equals, I don't know, let's just say it's 0.1, for example. Okay, so then we can calculate our force of friction, which is mu Fn, and in this case it's 0.1 because we're making up that number, times 9,800, which equals, and that would be 980 newtons, force of friction. And so what we're saying here is, in this icy patch, the force of friction, the maximum force of friction that can be supplied is 980. But we've already decided, based on this information, that in order to make a turn going 20 meters per second at an 80-meter radius turn, the car absolutely needs 5,000 newtons of friction. So what's going to happen to the car if it doesn't get the friction it needs? A lot of us have been in this situation, so we kind of intuitively know what happens. The car skids out. So what the car does is it hits this patch and then it skids out. So it does something like this. So what it's actually doing is increasing the radius, right? The new radius of this turn is bigger. If 80 is bigger, what does that mean about the force of friction required? It means it needs less friction. So when you talk about skidding out, I'm sure all of us have done it, skidding out. When you skid out, what that means is your car doesn't have enough friction, and you're basically increasing R, the radius of turn. There's two ways to handle a turn like this. One of them is to increase R, but if you look at this equation, mv squared over R, the other way is to decrease V, isn't it? Decrease V. If you're going really fast, you need a much bigger force in order to make a turn. If you slow down, you could probably make this 80-meter turn, but with a reduced friction, but going at a slower speed. So the two choices include either increasing your radius, so skidding out, or decreasing your speed, slowing down. And those are the two ways you could solve this question.